We are here to present research which we are carrying on with Italian trade unions about Industry 4.0 and the impact on labor. So, of course, our presentation very much connects to the one previously given by Tom. One of the main reasons we started this research was precisely that of trying to assess whether all these apocalyptic forecasts about Industry 4.0 and mainly the study you were mentioning, you were citing the Freire Moscow one, were actually likely to be going to appear as they are forecasted by economists or sociologists of labor. Our idea was that probably the methodology employed to make those estimates was not completely reliable. And actually I think that one of the problems we have as economists or social scientists or whatever is that we very often rely on studies that are made by using analytical and empirical tools which are basically mainstream neoclassical economics tools. And Freire Moscow study is, in my opinion, this case. So it is a study whose methodology probably is not to be shared if one does not share the ideas of the basis of neoclassical economics. So what we try to do with this study is, we have twofold aim. The first one is that of making interviews with workers on workplaces to see what's going on right now and which perspectives we have for the near future. Of course, nobody can forecast what's going to happen in 10 years, but we can have an idea of what's going on right now and which perspectives we have for the next, let's say, 1, 2, 3 years. And the second one was that of performing a more macroeconomic study, employing analytical tools which are not mainstream, not neoclassical, but belong to the classical tradition. So we mainly use input-output tables and data on international trade and so on to try to build international production chains. This connects also to what you were saying before. I mean, one of the graphs you were showing about the decline in employment in manufacturing. Of course, it is true that if we look at the manufacturing sector from national accounts, there is a decrease in employment in that sector. That has very much to do with two phenomena. One is the fact that big firms just externalized some services which were, in national accounts were accounted as manufacturing before externalization. They were accounted as services after externalization, but if one follows the production chains, so the subsystems as we would call following Rafa or Leontiev, we see that a great deal of employment in services is actually triggered by manufacturing. So it's services at the service of the manufacturing sector. So it could be somehow accounted for as manufacturing employment somehow, because it's not final consumer services. And this can be extended not only to the separation between primary, secondary and tertiary sector, but also to the separation between different countries participating in single production chains. So, for example, BMW is assembled in Germany, but a lot of its parts and components are produced abroad, then maybe are exported to a third, fourth, fifth country, and then finally all these parts and components go back to Germany and are assembled, and Germany provides the final commodity. This implies that German productivity in the automotive sector, for example, seems to increase very much, because actually the stages of production which are actually performed within Germany are fewer and fewer. And the most labor-intensive ones are externalized abroad, especially in Eastern Europe countries, for example. And so this might make, public opinion think that, okay, all labor reforms, labor market reforms which were implemented in Germany increased labor efficiency, and so productivity in Germany increased. Actually, it is a matter of externalizing abroad some stages of production. So you mentioned complexity and the fact that studies like most probably do not take account of such complexity. I think that this kind of complexity is very relevant. I am mentioning international chains of production because it might seem another topic with respect to the one we're talking about today, but actually we think that it is extremely related to the issue of technology and its consequences of labor, because the kind of automation you were mentioning, Amazon and whatever, are all automation which is applied in the logistics sector. The logistics sector is exactly the sector, the kind of services which are used to push further externalization and internationalization of production. So international division of labor and the very rapid change of its structure is relying almost completely on these new technologies, which are basically technologies which increase connectivity, so Internet of Things. Matteo then will go into more detail into this, but we are talking about technologies which actually connects to logistics and to the way in which production is organized and fragmented geographically as well. So we always listen to talking about, Chinese workers and Chinese products coming to Europe and substituting European labor, but actually the real substitution phenomenon is taking place within Europe. And this is very important from a political point of view, I think, because he was also mentioning the change in the structure of capitalism in the last decades. I think that one of the main changes which took place in the last decade is precisely that of, concentrating the ownership of means of production in geographical concentration of this ownership with an enormous dispersion of physical production. So we overcame the structure of national capitalisms we had before, so capital actually did organize transnationally. Labor didn't. So it is extremely important from our point of view to have a very good picture of how production chains are organized right now and how their structure changed in the latest years in order to organize workers from different countries. Otherwise what happens is that we have competition between workers of different countries, because when a plant is moved from Italy to Poland, from Poland to Russia or whatever, of course there is, in a period of huge unemployment, there is a strong competition between workers of different countries. What we want to do with this research, was extending it to other European countries and try to build a group of people, of workers from different countries, trying to think of a common strategy to be able to bargain some results in front of a capitalistic sector, let's say, which is very well organized and did organize in advance, many years before we started to think about these things. So, just very quickly, I don't know whether you can see from there, however, this is basically in the transport equipment sector. You see Germany, France, UK and Italy. And the bars you see are the percentage of autonomous domestic components used in the whole sector, and so let's say cars components which are produced within the country and which are produced abroad, directly or indirectly. So even if Italy produces a component, then sells it to Portugal, and then they sell it back to Germany, this is also something which goes from Italy to Germany through a set of other countries. So this is apparent not only in the transport equipment sector. We always talk about this because it's a sector in which we have been working a lot also with our interviews. And the domestic autonomous component of these production chains is constantly declining since, here you see data from 1995, but this decline started basically at the end of the 80s, beginning of the 90s. So the reduction of the autonomous components, of course, is accompanied by an increase of the component which comes from abroad. And we have countries like, I'm sorry, this is very small, but it is the third panel on the third row. you see transport equipment. So you see, for example, Bulgaria, Czech Republic, Hungary, Poland, Romania, Slovakia, Slovenia. All these countries increased enormously their participation to German production chains, manufacturing, of course, production chains in the latest years. This was made possible precisely by the adoption of this kind of technologies, which, on the one hand, allow to share the burden of production and disperse it geographically in a very, very fast way. This also means that things might change very quickly. So if now the tendency has been that of moving production from Western Europe to Eastern Europe, we start to see that this trend is going to change again. So we are starting to see externalization from Eastern countries belonging to the European Union to Eastern countries outside the European Union. So it's something which is changing very quickly. This is an example of how an international chain is organized. You see that there is a very complex network. Each node of the network in itself includes a set of other smaller networks, and the whole web is very, very complex. And having we need a tool to try to reduce this complexity and understand how it works. This is an example, I think you cannot read actually, but it's what Matteo is going to tell you afterwards, because we try to build back the network of connections between German automotive companies. The most famous is not, I think we all know everything, and some companies which are exactly the case studies Matteo is going to present in the second part of our talk, participating into these chains. So, and these relations, these industrial relations go from Italy to other countries, then back to Germany, to Japan, to Portugal, to, the web, the network is very complex. These technologies allow first what I said, and then also they also have another very important consequence, which is that workers are controlled in any moment when they are in their workplace. So these connectivity tools, smartphones, tablets, now they also have smartwatches, then they have some chips in the shoes, working shoes and so on. So each worker is controlled in every moment in which they are at their workplace. This is the so-called big data. Big data are collected exactly through the information workers themselves send to the machine they are using, and then to the central node of this network, and then it is a very powerful tool for control over labor, over workers, which is also something which trade unions should take into account in bargaining, because of course it's a very relevant part of working conditions on the working places. So to sum up, before giving the roof to Matteo, is that we have to take into account which are the characteristics of the European productive structure. We are talking about the European structure because Europe is very integrated. So the great majority of exchanges happens within the European Union. It's just a very small deal of international trade which takes place outside Europe, and mainly for final goods. While for intermediates, it's a very, very integrated area. So the productive structure is geographically fragmented and distributed because, of course, the European Union is characterized by the freedom of movement of capital, the freedom of establishment in the European Union, and it has been characterized in the last decades by a strong deal of delocalizations. Then production happened just in time, so there is no, this is a huge change with respect to some years ago. We don't have everything, the company receives an order from the customer, orders the inputs, produces the good which has been ordered, and sells it immediately. So there is no storage of inputs or finished commodities. Just-in-time production requires a very strict coordination and synchronization between the different parts of the of the production chain. The case of automotive industry is always used as an example, not only by ourselves, but basically by everybody who talks about this, because a car includes more than 15,000 parts and components, which means that dispersion of this production chain through Europe requires a very, very strong coordination of the different parts. And so the whole chain needs to be synchronized very strictly, and Industry 4.0 serves exactly this aim. So our take is that it does not, I mean, of course automation is a part of Industry 4.0, but what is really going to be disruptive is that part of Industry 4.0 which relates to connectivity, big data, logistics, and so on, because that is really the tool which capitalism, European capitalism, is using to create this first competition between workers, and second, disrupting a way of organizing production, geographically dispersing it. So there is a new structural division of labor across different European regions, new and continuously changing. Supply chains are segmented in levels which are hierarchically ordered, so especially again in the automotive sector there is the first tier, second, third, so there are a set of levels of suppliers which are connected to the head of the production chain, while the head of the chain is the final stage of production, so final assembly. This structure is integrated and transnational within European Union. Suppliers under the authority of firms at the head of the chain decide, the head of the chain decides everything: quantities, delivery times, costs, technology, standards, organization, everything. So there is kind of a monopsony. So the head of the chain basically rules what suppliers can or cannot do. And in some cases, the degree of integration of these stages of the chain is so strong as to blur completely boundaries between companies. So there are new forms of cooperation and corporate governance which are transnational and therefore are out of the control of traditional bargaining, which takes place on a national basis. This is the problem. Companies are organized transnationally, labor isn't. So Matteo and I now will just talk to you about the case studies.
Okay, as described by Nadia, the main goals of Industry 4.0, it has been defined by German project, Industry 4.0, and the main goals are networking the different parts located in different countries, but of the same production chains. Even they are located in different plants or countries. And so we can, more specifically, we can talk about horizontal integration through value network. That is, the different parts of the same production chains, different factories, supplier, subcontractor, external designer, and so on, are strongly integrated. And second, we can talk about vertical integration. Within the same plant, the different function, R&D, planning, design, manufacturing, are strongly integrated and communicate with each other in real time. The key tool to realize these smart factories, or better, these smart chains, is the Internet of Things, IoT. That is embedded devices with internet address, with internet protocol, make it possible the interaction and the communication between machinery, human beings, product, parts and components. We speak about M2M, machine to machine, M2H, machine to human, and so on. And this generates the so-called CPS, Cyber Physical System, that is realized both by material components, sensor, RFID, barcode scanner, smart machineries, etc., and by software tools. And this cyber-physical system generates a massive amount of data, the phenomenon of big data, which are used in real time by firms. Detailed monitoring of business model will play a key role in documenting processing steps and system status. In particular, the individual steps of production process will be tracked at any time, and the use of data also feedback on the entire production chain. Now we will present some case studies from Italy. The first is the MIDAC. MIDAC produces batteries for automotive sectors, and is applying the Toyota production system, whose principles are first, the continuous improvement, the Kaizen in the Toyota system, to grant technological innovation and productivity maximization. Second, the famous just-in-time production, that is, producing or acquiring only the exact amount of inputs which are required in a specific point of time. And this implies, of course, balancing and fine-tuning of the production chain as a whole, starting from market demand and planning. Three, to create a smooth and continuous workflow characterized by both flexibility of production, but at the same time by strong coordination of all different parts, from the first supplier, manufacturing, to the logistics, and so on. And finally, quality is monitored in each production stage. On the basis of this Toyota's pattern, MIDAC intends to realize some investment in Industry 4.0 technologies. In particular, computerized production process, in particular, the sequence and the progress of each production stage with ICT tools, in order, of course, to control in real time over all steps, so that productive lines are monitored to collect data about the start and the end of each operation. Two, install the PLC, programmable logic computer, on all the machinery of the plant to monitor in real time produced output, quality, and execution time. And moreover, with monitor and smartphone or smartwatch and so on, the system will communicate with maintenance services to reduce the recovery time. Four, introduce 3 or 5 new robots to realize hard and monotonous tasks. And finally, install devices for remote control on batteries. In the case of MIDAC, there are 2 types of network. First, MIDAC is at the center of a complex network of suppliers. Lead boxes, covers, sulfuric acid, steel, etc. In order to optimize the production times, all these suppliers must be carefully synchronized. And second, the second type of network, the battery is produced only by order of car makers, BMW, Audi, Porsche, Renault, Peugeot, and so on. Thus, also production planning must be carefully defined and realized in just in time. In particular, the charging of the battery, since it must deliver exactly when car maker is going to assemble it. The second case in the automotive sector is the Magneti Marelli. Magneti Marelli supply big car maker, original equipment manufacturing, such as Fiat in Italy, but also Audi and Porsche. And in particular, Porsche adopted a productive model which allow customers to order online, customizing their vehicle. The order is managed by a centralized informatics system that allow to synchronize all the actors involved in the chain. The plant located in Corbetta, near to Milano, periodically receive production plans through EDI, electronic data interchange. This is important because 5 days before the assembly takes place in Germany, Magneti Marelli in Milan received via VAN, value-added network, the order to start producing a specific sequence of board tools, and then the board tools will be assembled in a Porsche plant. EDI, electronic data interchange system, allows to share documents between informatics systems. That is, partner can electronically share orders, transport documents, invoices, inventories, and so on, through a common language with defined standard integrated with ERP. Moreover, Magneti Marelli use a particular software, TESA, Motis 1 and Motis 2. The first one, Motis 1, is a software for production planning and scheduling to optimize first the workload of each machinery and human being, and second, the performance and the productivity of the entire company, taking into account of priority orders, deadline, inputs, potential departments, machinery processes, throughput times, unproductive time, and so on. And the second software, Motis 2, is a software for production management, collection of data, and monitoring. Is a mess manufacturing execution system. It allows to control and manage, one, statement of progressing activity, and two, the automated monitoring of production parameter of each equipment. And the interactive management generates a complete and powerful system of supervision in real time of the production process as a whole. In Magneti Marelli, each machinery embeds the software it uses. For example, the pick and place machineries are controlled by a program that identifies the right components to be placed on circuit board. Second, each machinery generates data which are collected daily, and this allows, of course, for monitor the line as a whole, because a screen is located in each line, and the production responsible from their station can see in real time the functioning of each machinery and each line. And moreover, each machine tracks the beginning and the end of each production stage and performs its operation within a specific time. 3. The Carrel. Carrel produces product for temperature control for shopping malls, restaurant, hospital, and so on. And the firm wants to realize a machine-to-machine connection through a software that connects the entire plant and the different plant of the same company, in order to offshoring, externalization, and so on. The system is linked to a server that collects all information and manage production processes. In this way, the proper implementation of tests will be ensured by a software that connects all machineries and all productive lines. And some machines must assemble many parts and components. To avoid workers' mistake, Carrel uses informatics system, MES or other software, to recognize the component to be installed. The worker uses an optical reader to recognize the code which is associated to a particular production order. And the system, in this way, controls both the whole production process in each single machine, and second, but most of all this system can control workers' performance in real time. All the process collect data, and the data are visible on a monitor, the effect generated by process control are verified, all data are synchronized, and so on. And Karel, the company's goal is to plan and manage the entire production process in real time. Starting from information given to the system itself reacts by planning the production of order by customer. From the organizational point of view, MES, manufacturing and execution system, translate information taken from Oracle, the planning system, into work order for production line with a daily schedule. And second, MES monitor the process of production, identifying the current stage and the specific operation in progress, and immediately detecting any problem. Moreover, also in this case, it tracks what each single worker does in each single moment. Operation times are established by Oracle and managed by MES. Each worker with an optical scanner or a touch screen, PC, and so on, read a barcode which initializes the corresponding operation. Thanks to this system, the firm can trace the process as a whole, from the input given by supplier to final product given to customer. There is a flow from supplier to customer and other way around. Still on the subject of integration, the company has realized the interconnection between internal logistic, warehouse system and so on, and ICT system of express couriers such as DHL, UPS, TNT, FedEx and so on. The ultimate case is the constant that produce refrigeration equipment for industrial and commercial use and so on, and the constant intent to utilize Internet of Things in order to connect machine and plants that communicate with each other and with human beings. Big data, the analysis of massive data allows to develop new product and process strategies. 3D printing, not only for prototypes, but in the future also for spare parts. For digitalization of the entire production process to improve flexibility and new robots to support human work. There are two departments most automatized, the department of door construction and metal sheeting. Sheeting, sorry for my bad, sheeting is a basic metals, okay? For example, in the metal sheeting department, the sequence is: first, customer send the order. Second, a software, SAP, calculates the input requirement for its realization. 3. MRP verify availability of material and indicates the missing inputs. 4. A software called JetCam generates information for each machine, CAM, computer-aided manufacturing. And finally, NICIM, schedule production. This system is completely connected and gives the information of production order to the machines. The machine operating on steel works 7 days, 24 hours, even on Saturday and Sunday when the factory is closed. In this way, on Monday, workers find the piece ready to be used. When the plant is closed, an automatic warehouse provides inputs to machineries and after production process stores them. Also, in the case of custom, it is important to stress the importance of networks, both with suppliers and other plants of group. First one, with closer suppliers, a Kanban, Toyota system, exists. An operator pushes a button and automatically a supplier receives an order. For example, when steel is needed, an operator pushes a button and steel supplier must deliver it within 3 days. And second, the second type of network, a similar system also exists among custom plants located in Italy, France, UK, Sweden, Denmark, and so on. Plants focus on a specific production, and some of them provide other plants with components. For example, the machine producing the shelf of the fridge is located in France, but it produces shelves for all other plants by orders via Kanban system, and the nervous system that distributes this information is a software called SAP. Finally, the impacts on labor, as described by Nadia, the main risk is the increase of employment level, is the increased possibility of delocalizing production stages, especially within European production chain. And the second impact is the workers' control. That is, cyber-physical system allow to monitor continuously and in real time the whole production process. Data collected by devices everywhere in the plant are uploaded to the network, CPS, in real time, and again in real time are analyzed and processed. This means that firms can continuously control workers' performance. Moreover, production processes are going to be planned machine to machine, or machine to product, or product to product. Attention, machine to machine, machine to product, product to product. This implies that the role of workers is going to radically change. In most cases, they could become a mere appendix to machines. And the question is, will labor organization be collectively bargaining, or will labor condition be decided by company software or other similar tools? And finally, there is the issue of quality of job. The risk is that of de-skilling, which can affect high-level position too, since software and algorithms can realize a great extent, for example, design activities. In other words, technology can pull knowledge and best practice out of the workers' know-how. Thank you for your attention.